The domain is the set of all x values that can be used and the range is the set of all the y values. So if we have a graph, let's say that starts here and it goes to here, and this should not go straight up, of course. The domain is going to start with the x value that's farthest to the left. We'll just call this x1, and run to the x value that's farthest to the right. So in this case, the domain is going to be this set of x values from here to here. And since both of these points are colored in, these are included, so we're going to use brackets. So the domain in this case, if we put it in interval notation, is going to be bracket x1 to x2, or if we put it in set notation, it would be the set of all x's such that x1 is less than or equal to x is less than or equal to x2, where x1 and x2 are both going to be numbers. So for the domain, you always find the point farthest to the left and the point farthest to the right, and as long as there aren't any breaks or gaps of any kind in the function, it's just going to go from one to the other. If we look at the range, to find the range, you want to find the point that's highest up and the point that's lowest down. These may or may not have anything to do with the endpoints on the graph. In this case, the lowest point, I'm going to call it y1, and the highest point, I'm going to call it y2. So this is some kind of an x, comma, y2, some kind of an x, comma, y1. The range, since both of these points are included, is going to go from y1 to y2, or we could say it's the set of all y values such that y1 is less than or equal to y is less than or equal to y2. Now I want to remind you that in interval notation, you must always put the low number first and the high number second. And since we read from left to right, this comes really natural in the domain. But because we read from the top of a page down, this comes much less naturally for the range. And so there's always a temptation to want to put the y2 first and then the y1. And this is going to be counted wrong because this is incorrect as far as interval notation is concerned. There are two things that restrict a domain. And this is algebraically. Number one, You cannot ever, ever, ever divide by 0.
No.
Number 2, we cannot take an even root of a negative. This is because when we're talking about graphing, we're restricted to real numbers. So I isn't going to be involved here. So let's say we've got a graph of, we want to graph f of x equals 1 over x minus 5. We cannot have the graph be 1 over 0. This would be undefined. This is going to equal 1 over 0, therefore, if x minus 5 is equal to 0. So x minus 5 cannot be 0. If x minus 5 cannot be 0, then this says that x cannot be 5. To leave 5 out of the domain, that means that 5 can be any number below, or x can be any number below 5, or x could be any number above 5. The only thing it can't be is 5. Since this end of the graph is negative infinity and this end of the graph is positive infinity, then this interval is the interval from negative infinity to 5, using a parenthesis because the whole point here is to leave out the 5. And if you use a bracket, that means you're including the 5. This interval would be every number from 5 to infinity, again using a parenthesis on the 5. Either of these is part of the domain. The only thing we have to do is leave out the 5 itself. So we put a u in them to say that it's the two of these. So it's from negative infinity up to 5, but not including the 5. And then from 5 to infinity, again, not including the 5. This is the same thing as x is not equal to 5. Let's do another example. Suppose we have f of x equals the square root of 2 minus x. In this case, 2 minus x has to be greater than or equal to 0 because this means the same thing as not negative. There's actually 3 possibilities. It can be positive, which would be greater than 0. It can be negative, which is less than 0, or it could be 0, which is equal to 0. 0 is not considered positive or negative. So if we say 2 minus x has to be greater than or equal to 0, that's saying it's not negative. This, if we subtract 2 from both sides, gives us negative x is greater than or equal to negative 2. And then when you change this to a positive x by dividing by negative 1, because this is an inequality, we have to turn the sign around. So this is going to leave us with x is less than or equal to positive 2. Now this makes sense, because if we let x be 2, this would be 2 minus 2 is 0. If x was a number smaller than 2, say 0, this would be the square root of 2 minus 0, which would just be the square root of 2. which is irrational, but it is a real number. As long as we don't get a negative in here, we're okay. So here, if we're looking on the graph, we want to make sure that x is any number below or equal to 2. That would be down here below 2, or in this case, equal to 2 is okay. So we would put a bracket So since this is the part of the graph from negative infinity to 2, inclusive of the 2, the interval notation would be parentheses negative infinity to 2 with a bracket. Remember, we always use parentheses with plus or minus infinity. What if we had both a radical and a fraction to deal with? What if we said f of x is the square root of x minus 3 divided by x minus 5? Now we've got both situations. So x minus 3 has to be greater than or equal to 0, and x minus 5 cannot equal 0. This, if I add 3 to both sides, gives us x is greater than or equal to 3. This, if I add 5 to both sides, is going to be x is not equal to 5. So x is any number greater than or equal to 3, except for 5. Well, let's put the 3 and the 5 on a number line. Take a look at this. Okay, x can be any number greater than or equal to 3. That would be from here up, except it can't be the 5. So to leave out the 5, we do it like that. This is how we leave out a number on the graph. So we're going up toward positive infinity here. So we've got an interval, bracket 3 up to 5 with parenthesis, and then we have a second interval from 5 to infinity. This keeps the denominator from being 0, and being greater than or equal to 5 makes sure that what's in the square root is going to be positive.